Have you ever been talking to an AI and it just forgets something you told it like 2 minutes ago? It's wild, right? These things can write poetry, they can code complex software, but they can't remember your favorite color. So today we're going to dive into this really frustrating paradox and a brilliant new fix that's inspired by the best memory system out there, our own brains.
So here's the deal. The real issue is that even the most powerful large language models, LLMs, they really struggle with long-term conversations. And this isn't just a small bug, it's a huge roadblock. It's what's stopping them from becoming truly useful partners for complex, ongoing projects.
I'm sure you felt this. You spend all this time carefully explaining the details of a project, and then maybe 5 prompts later, the AI asks a question that makes it obvious it's completely lost the plot. It feels like you're just hitting the reset button over and over and over again. So what is actually going on here?
Well, a huge piece of the puzzle comes down to some technical limits. AIs have this thing called a fixed context window. You can think of it like a very small amount of working memory. They can only pay attention to a certain amount of information at once. And on top of that, researchers have found they have this lost-in-the-middle problem. They're pretty good at remembering the beginning and the end of a chat, but all those crucial details in the middle, they just get fuzzy.
And this really gets to the core of it. You can see the huge difference in strategy. Current AIs try to just brute force memory. They process everything, which is incredibly expensive and, honestly, super inefficient. Our brains, though, they're these elegant filters. We're constantly throwing out junk information, organizing the important stuff, and then storing the key takeaways for the long haul. It's that efficiency that AI has been missing.
So it makes you think, right? If we want to build a better memory for an AI, why not learn from the absolute best? Researchers did exactly that. They turned to the blueprint of our own incredibly effective memory system for inspiration. Let's see how that led to a real solution.
Okay, this is a classic model from psychology, and it's actually beautiful in its simplicity. So first, all the data from the world hits our sensory memory, which is just a super quick buffer. Then, whatever we're actually paying attention to moves into our short-term memory, where we're actively working on it. And finally, the really important stuff, that gets packed up and filed away in long-term memory. It's a simple, 3-stage pipeline for making memories that actually stick around.
And that brings us to the breakthrough. It's a new system called LightMem. And what it is an AI memory architecture that's specifically designed to copy that efficient 3-stage process we just saw in the human brain.
And you can see their thinking right in the research paper itself. They say they were inspired by the efficiency and structure of human memory. Their goal wasn't just to give AI more memory, but to give it smarter memory, by cutting out all the noise and focusing only on what matters, just like our brains do. So, how in the world do you take that biological inspiration and actually turn it into code? Let's pop the hood and break down how LightMem is built. You're going to see the parallels to our brain are crystal clear. Look at how this lines up almost perfectly. LightMem has a sensory module that starts by compressing the raw conversation, filtering out all the repetitive, useless words. Then, a short-term memory module takes that filtered info and groups it together by topic. And finally, a long-term memory module stores and updates those organized memories in a really clever way. Now, to really get why this is such a big deal, you have to understand a major flaw in older systems, something called hard updates. So, imagine you tell an AI you're planning a trip to Tokyo. A little later, you ask about trains to Kyoto. A traditional system might just overwrite its memory, replacing Tokyo with Kyoto, and boom, the original context of your trip is gone forever. LightMem totally fixes this with what the researchers call a soft update. Instead of just overwriting it, it appends the new information. So the memory becomes the whole story. You were planning a trip to Tokyo, and then you asked about Kyoto. The key is the context is never lost. It builds a complete, evolving picture of the whole conversation.
All right, so the theory sounds amazing, but does it actually work in practice? Well, the performance numbers are pretty staggering, actually.
First up, the cost. By filtering and compressing all that information up front, LightMem cut the number of tokens, which are basically the little pieces of text the AI has to process, by up to 117 times. That is a massive drop in how much it costs to run these things.
Next, let's talk efficiency. Because it's smart enough to group information by topic before summarizing, it had to call the main LLM up to 159 times less often. Fewer calls just means a much more streamlined and less power-hungry system. And, of course, that all adds up to speed. All these clever efficiencies mean the whole system can run over 12 times faster. That is absolutely critical if you want AI assistants that actually feel responsive and can work in real time.
But here's the real kicker. It's not just faster and cheaper, it's actually more accurate. When they tested its ability to answer questions about really long conversations, LightMem blew past a strong existing system. It boosted accuracy from around 62% to over 68%. So by remembering better, it ends up understanding better.
So look, this is way more than just a small step forward. Giving an AI a reliable, efficient, long-term memory fundamentally changes what we can even expect them to do for us. Just think about it for a second. Imagine a personal assistant that actually remembers your preferences from months ago. Or an AI agent that can manage a year-long research project and never lose a single detail. This opens the door to much more reliable AI in really important fields like healthcare. And because it's so much more efficient, it makes powerful AI way more accessible to everyone.
You know, this final quote from the paper really just drives the whole point home. It shows that by being smarter about how you handle information, by filtering, organizing, and consolidating, you can build an AI that's not only cheaper to run, but also smarter and more coherent over the long haul.
Which leaves us with a really fascinating question to think about. If you had an AI that literally never forgets, what complex, long-term goal would you hand over to it? Would you have it help you write a novel, keeping track of every character and plot twist? Or maybe have it sift through decades of scientific research to find new connections? Let us know what you'd do in the comments. We'd love to hear your ideas.